Hi, welcome to my video on solving related rate word problems number 1. Before I start to solve the related rate word problems, let's go through a few steps that most people would follow in doing these problems. The steps in solving related rate word problems, number 1 that I do is I state the given, and then I state what the problem is asking you to find, and then I draw a diagram, and then I state the equation or equations representing the given and or the unknowns, and then I do DDT for both sides of the equation, and then when I get that done I fill in the information, and you might have to find more information, and then I solve the equation for the unknown. So that's the steps that I'm going to do whenever I do related rate problems, which is what all the rest of this unit is on, solving related rate word problems. Many examples. So let's start with number 1 problem first in this video. Number 1, find the value of the rate of change in the parameter of a rectangle if the rate of change of the length is 4 meters per hour and the width is 3 meters per hour. So I'm going to follow the steps. And follow the steps is, let's see what I'm given. I'm talking about, or the problem is talking about a rectangle. And in that rectangle, they're talking about the rate of change of the length. So that's dl, dt, and the rate of change of the length is 4 meters per hour. And also they have the rate of change of the width, so that's dw dt, and that's 3 meters per hour. Okay, let's spell that right. And so that's the given. I have a rectangle, and what do we have to find? Well, let's put down what we're looking for. We're trying to find, it says the value of the rate of change. The value of the rate of change of the parameter. So the rate of change of the parameter, so that's dp dt. So that's, I'm trying to find the value of how the parameter is changing in relation to time. And as a result, what we try to do is, I set up talking about a rectangle. So let's draw a rectangle. Rectangle is a 4-sided figure with all right angles, and we should know that by now. And it has a length, width, and width. And it's talking about the parameter. So in relation to the parameter of a rectangle is the distance around, so it's 2 lengths plus 2 widths. So in relation to this equation, we're going to do so we have the parameter, the length, and the width. So we're going to do dp dt. So we're going to do d dt on each side. So d dt here gives me dp dt. And d dt on 2l, the derivative of 2l is 2, and it's dl dt. And the derivative ddt of the 2w, derivative of 2w is 2, and it's dw dt. And as a result, we want the parameter changing in terms of time. So dl dt, so that's 2 times dl dt is 4 meters per hour plus 2 dw dt is 3 meters, let's put a stroke there, 3 meters per hour. And we work that out, we get 8 meters per hour plus 6 meters per hour. And we add them together, we get 14 meters per hour. So that's the rate of change of the parameter. It's 14 meters per hour. So that's one done, but I'm going to follow the same strategy each time. And here we go. Let's try another one. Number 2. Find how much the area of a triangle is changing. If the height is 6 times the base rate change is 1.8 feet per second when the base is 12. So again, what I do is I write down what am I given in this problem. Well, I'm talking about a triangle. Okay, we have a triangle, and it says we have the height is 6 times the base. So let's call H the height and B the base. So the height is 6 times the base. The base rate change is 1.8 feet per second. So the dB dt is 1.8 feet per s of seconds. And we also have that when the base is, that's B, is 12 feet. So that's what we're given. And we have to find, so it's asking me to find how much is the area of the triangle changing. So that's the area, the dA dt. So that's the area changing in terms of time. And we have a triangle, so let's draw a diagram because it helps us. If I have a triangle and the area of the triangle, if we let the bottom of the triangle be the base, and this is the altitude coming down to the base, or the height, we call that the height perpendicular to the base. So we talk about how much the area of a triangle. So the area of a triangle is A equals a half the base times the height. So I can do d dt on this equation right here, but I have the height is equal to 6 times the base. So if I replace the height or the base in relation to each other, then I only have the area in terms of the base, or I could have the area in terms of the height. But because this is a base changing in terms of time, because I have a base of 12, then let's substitute the height with 6b. So that means the area, half of 6 is 3. So the area, based on these conditions, is 3 times b. Oh, almost did a cube there. 3 times b squared. So now we have an equation. So the next step is to do the ddt on each side. So ddt of the A is dA dt. Derivative of 3b squared, 3 times 2 is 6, b to the 1, and it's dB dt. So now we have we're trying to find how much the area is changing in terms of time. So we have 6, the base is 12 feet, and we have dB dt is 1.8 feet per second. And so we have to multiply that, and when we multiply 6 times 12 times 1.8, we'll get 129.6, and feet times feet is feet squared over time. So based on these conditions, the area of the triangle is changing at 129.6 square feet per second. So that's 2 examples of doing related rate word problems using implicit differentiation that we practiced in the previous videos on related rates. And that ends the first video on related rates, and there's more to come. If you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. And I thank you for viewing my video. Hope the video helped you. Bye-bye.